In this course, we break down the analysis phase of the of systems analysis and design into three parts. The first part, we talk about investigating the system requirements. In other words, discovering what exactly does the system need to do and how does it need to work. And then we take all the raw materials that we learn about in this unit and we turn those into use cases, which we learned about in the next unit. And then we learn about domain modeling in the next unit after that, which is where we try to model all the different things and stuff that's in our system. And then we extend all that stuff into activity diagrams and communication diagrams, some existing or some additional diagramming techniques that we'll learn about. And that's basically all the systems analysis stuff. But the important thing is this analysis phase is all about understanding what the needs are, understanding how the system needs to work. And I know that in the simple example that we did, it was real easy to understand what they needed, but sometimes in more complicated systems, it's a much more daunting task to understand exactly what they need, especially if it's something that we don't know a lot about. I think as a systems analyst, most of us that work as a systems analyst or have worked as a systems analyst, our primary role is that of a technologist, right? Somebody who understands technology, but we also have to have some understanding of the business as well. And it's kind of hard to find people that have a real strong knowledge of both of these areas. And that's where a systems analyst has to really have a good skill set in being able to understand things that are not their primary area of expertise. For example, I went to school, like all of you are, for in information technology and informatics. When I got into the industry, I found myself in the medical and radiology field as an information technologist, and I don't have a lot of experience. I didn't really know much about radiology, so I had to develop the skill set for really trying to understand how radiology works and how hospitals work. So I don't know much about, at the time I didn't really know anything about the medical industry. It was not what I was trained to do. But I had to quickly understand all that stuff in order to help develop, design, and maintain systems that support that industry. So again, a big part of our job as a systems analyst is to try to understand exactly what the needs are and understand the workflows, understand the business. So to that end, in this unit, we're going to talk about, first we're going to discuss the case example. So the RMO case, that company that sells clothing and whatnot for outdoor activities. So we'll look at that first and try to apply some of these concepts. Then we're going to talk more specifically about how we gather requirements. We're going to talk about what stakeholders are, the techniques for gathering these requirements, and then modeling techniques. So we'll discuss a little bit more about modeling. We'll really start to dive into what modeling is. But we don't really start to do a lot of modeling until the next unit, in Unit 2. So let's get started to talk about the case. So RMO, which is our example case, has an elaborate set of information systems that support both operations and management. So customer expectations, modern technological capabilities, and competitive pressures are leading RMO to believe that it's time to upgrade support for sales and marketing. So they've got these legacy systems, and they want to upgrade them and bring themselves into the 21st century. So they're going to develop a new consolidated sales and marketing system. This is the idea. So it's a huge project for them. So it's it takes a lot of planning, and this is what we're going to talk about through most of the semester with the case example. So first, they have some strategic planning to do and competitive advantage, which helps them gain a competitive advantage. So they're thinking about the future. What can we do to improve? Our book talks a little bit about what an information system strategic plan is, which is basically the overall strategic needs of the organization. So in other words, the information system strategic plan is how to basically plan for better systems to support the business functions or the core business. So it includes a definition of technology architecture and application architecture. Well, what is technology and application architecture? Well, technology architecture is the hardware, the networking equipment, the topology, all the different systems that are employed by the organization. So this is the infrastructure you can think of in the technology architecture. So it's the virtual machines, it's the databases, it's the networking stuff, the telephones, all that technology that supports the business. Application architecture is a little more abstract. Here we're talking about the information systems that actually support the organization. So These would be the systems and subsystems that are supporting the company or supporting the organization, supporting those business processes. So technology architecture, so in other words, application architecture sits on top of technology architecture. You have to have, obviously you have to have technology architecture in order to run the application architecture. But you can't have application architecture if you have no technology architecture. There's nowhere for it to run. I always use the example of a fish tank, right? A fish tank is, you've got the tank itself, and the tank holds the water, and in the water are the fish. What we really have a fish tank for, the whole purpose of having a fish tank is for the fish, because we like to look at fish. But we have to have the water in the tank in order to hold and give we need the water because the fish have to swim in the water, and we need the tank to hold the water in. If we don't have the tank, there's nowhere for the water. If we don't have the water, the fish can't survive. Our applications are like the fish. It's what we really want. But we have to have that technology architecture, which would be like the tank and the water, to support that. So, no company goes out and says, we want to have the latest technology just to have it. Well, maybe some companies do, but they probably aren't very profitable. But most companies don't want technology. They have to have technology in order to support the applications which support the business processes. So that's the important concept to take away from that. So let's take a look at what they have right now. So this example company, the RMO, they have a supply chain management system. So it's about 5 years old. It uses Java with Oracle. This is what that trade show system that we developed in the previous lecture would interface with. Then they've got a phone and mail order system, which has been around for about 12 years. So if we recall, if you read in the book, this example company started originally as a phone and mail order company, and they had one location, and they built out those locations, but they do a lot of phone and mail order. So it's about 12 years old, uses Visual Studio and Microsoft SQL Server, which you could tell is completely different from Java and Oracle, so two completely different systems. So they've reached capacity, and it doesn't have really any capabilities for integration with other systems, so it kind of just sits off by itself. Then they've got another system they use to manage the retail stores, so some kind of point-of-sale system. So it's a package solution. So in other words, they purchased a point-of-sale system. Again, minimal integration. So the retail store management system doesn't talk to the phone and mail ordering system, and neither one of those really talk to the supply chain management system. And then we've got a customer support system, which is a web-based system that's evolved over the years. So just a tool for customers to be able to go and manage their accounts and things like that. So again, not a lot of integration with the other systems. So what we have here are 4 silos of information systems. So maybe in the strategic plan for this little company, somebody said, you know what, it would be a good idea for us to consolidate all of this stuff into one system. And then maybe this is what that's going to look like, that one consolidated system, and this is how all the stuff is going to talk to each other. So you'll have one warehouse system that receives shipments, and that warehouse system, subsystem, would be able to send the shipments to customers, send shipments to the retail stores. The retail store system supports the retail sales. The warehouse system supports phone sales. The web-based system supports the web-based sales, and all this stuff all put together. So this might be an example of what our consolidated system might look like from a high level. So here are the 4 subsystems that perhaps we've identified. There would be a sales subsystem, an order fulfillment subsystem, a customer account subsystem, and a marketing subsystem. And all of these together would create our new consolidated sales and marketing system. So our sales subsystem would integrate online, phone, and retail orders. So all of the different orders, instead of having one system for retail, another system for online, and another system for email and phone orders, instead it would all be one big system that handles those orders. Whether it's a sale on the store, on the phone, or online, it's all in one system. And then a different system would be responsible for fulfilling all of those orders, which would be shipping, tracking those shipping, and other services and things like that, and returns and all that stuff. A customer account system would track all of our customers, allow them to see their history. So whether they purchased in store, purchased online, or purchased on the phone, they'd be able to see their history. And Mountain Bucks, I guess, would be like a little rewards card, like we all have on our keychains. And then a marketing subsystem, which would have promotional packages and maintain partner relationships. That'd be like a sort of a relation management system, something like that. So these are the subsystems that we're going to have in this new system we want to develop for RMO. So some of the activities that we're going to perform initially to discover the requirements. So we're at the phase now. We know what the subsystems are. We've got that strategic planning goal that tells us what we want to do, and maybe there's some preliminary approval to move forward with the project. So first, we have to discover and understand the business processes and business rules that the system has to capture. So I showed you those 4 subsystems, and if you think about it, each one of those subsystems is like a system all unto itself. So it's a pretty complicated system. Lots of business processes and business rules that we have to capture. And that's one of the big challenges with systems analysis, obviously. So the SDLC indicates that the project starts with identifying the problem, obtaining approval, and planning the project. So we're kind of assuming here that we've already done that. In a more traditional systems analysis and design course, like a structured systems analysis and design course, your whole first 2 or 3 units would probably be all about identifying the problem, obtaining approval, and planning the project. Here at Drexel, in this course, we have to focus on that object-oriented systems analysis and design process. In other courses, we'll talk about planning the project and some of that more high-level business stuff that we talked a little bit about in Chapter 1. In this course, instead, we are going to jump right into the analysis phase. So we're going to jump right into the analysis activities, so we can kind of hit the ground running. So again, we're kind of assuming that we have approval and and all that stuff. And we'll talk a little bit more about stakeholders later on, because that is important in projects and to help ensure the success of your project. But again, there are, of course, lots of things that have to be done before we get to this phase. But we're going to start here with analysis in this unit. So again, project planning and project management, all stuff that you can learn about in other courses. And again, I do have some supplementary material that you can look at if you want to get up to speed on project management. So first, we have to determine the requirements of our project. So how do we do that? How do we determine? We have to gather information. And how do we gather? Well, there's lots of different techniques we can use. We can do interviews, questionnaires. We can look at documents. By the way, sometimes I call that artifacts. So when we collect things, like our reports and things like that in forms, I call those artifacts, but we can look at that type of thing. We can observe them in the process of doing business. So observation is a powerful tool for a systems analyst. We can look at what other vendors are doing. So there might be packaged software that already does all this stuff. So you can look at some of the documentation of those systems, and it can help give you some insight as to what your system needs to do. Sometimes I call that baselining. So you might hear me use the term baselining. That's when we're looking at what other people are doing. And then comments and suggestions, what people have said would be a good idea. In the analysis phase, we're also defining those requirements. So in order to define the requirements, we're going to use some modeling techniques, which we're going to talk a little bit about in this unit, but we'll get more into that in Unit 2. And we'll break those into functional and non-functional requirements. Most of our modeling is going to be around functional requirements. We'll talk more about that in just a minute. We're going to prioritize the requirements. So we're going to try to determine what is essential for the system to meet the requirements and what's just things that are nice to have. Users, when you ask them, what do you want? Sometimes you get these sort of pie in the sky, here's all the cool stuff that I want to do. One of my favorite examples in my industry, I work in radiology, and you'll be talking to a customer, and sometimes you feel like hospitals ask for all these crazy features in the systems that we use to support radiology, and sometimes it almost feels like they're asking for a system that can just tell you what the pathology is of the patient. And I always say, well, if it were that good, what would we need doctors for, right? So, sometimes you just have to whittle down to what the essentials are. What do we really need? One of the big things that I always have to deal with in the radiology space is clicks. I always have radiologists tell me, the doctors that read x-rays, they're always saying, well, I have to be able to read my x-rays in less than 3 clicks or something like that. Amazon can sell me something in 1 click. How come you guys can't show me images in 1 click? And, while it may be possible to do that, there are other bigger fish to fry, other more important things in the workflow to worry about. So, saving a couple of clicks isn't always so important. And sometimes you have to know how to deal with that with the users. we're going to develop user interface dialogue. So in this phase of analysis, we can start developing what the user interface is going to look like. And that helps our users envision exactly how that system is going to work. And also gives them an idea of the flow or interaction between them and the system. So again, it gives them some insight as to how the system is going to work, and they can give you even more insight as they're going through those interface dialogues. We're going to evaluate requirements with the users. So we have to involve the users. We're going to get some feedback. So we're really trying to really shape the requirements for this system and make sure we truly understand exactly what the needs are. So what are requirements? System requirements can be functional or non-functional requirements. So functional requirements are the activities the system must perform. So these are the things the system has to do. So functional are all the things that you sit down and specifically tell the system to do and the system does for you. Those are your functional requirements. But we also have non-functional requirements. So non-functional requirements are other characteristics, other things that the system needs to do. Some examples would be constraints and performance goals, and we'll talk about some more of those other requirements. So FURPS is an acronym, which is an industry standard. It stands for functional requirements, usability requirements, reliability, performance, security, and other categories, which you can expand on. So these 5 are the basics, the FURPS. If you remember FURPS, you're always going to focus on the functional requirements, and then you've got usability requirements, reliability, performance, and security. So what are all those other requirements? Well, usability is how easy it is to use the system. Reliability is the availability of the system. In other words, the system is available to use. Performance is how well the system works, or how fast the system is, or how well it scales to hold all the data that it has to hold. And security is the idea of confidentiality and integrity of the data in the system. And then you can add on some additional categories that might be important for your organization. So what are these? Let's expand on these just a little bit. We already know what functional requirements are. The rest of these, after functional, these are all non-functional. In other words, they're not specific functions in the system or the specific things the system do, but there are requirements that we have to have in order to be successful. So, for example, usability requirements. Give an example of that. If you're developing a system that's being used by employees of a company versus a system that's going to be used by the general public, like a web page, the usability requirements between those two systems will be very different. If you have a population of users that you're able to train, then you can sacrifice some usability because you know you're going to have the ability to train them. Whereas when you have general public users, you know you can't train those users, and it's imperative that those users be able to use the system. Otherwise, they're going to go to your competitors. So in that case, usability requirements become much more stringent. It's important to know where you stand with usability requirements. Sometimes you have complex processes that you have to implement that are difficult to make usable to the point where you don't need training and you don't have to have skilled users. But at the same time, sometimes you have the general public trying to do complicated things that you do have to spend a lot of time with usability to make sure they're going to be able to use the system. So that's how we relate to usability requirements. You've got reliability requirements. How available does the system have to be? So take, for example, a web-based system for RMO, which was our example case, versus the retail system. The web-based system has to be available 24/7, all the time, 24/7, 365. You never know when someone's going to go online to try to buy your product. And if your system, if the web page doesn't work, they're going to go to somebody else's web page and buy it. So that's lost opportunity, lost sales. The flip side is, in a retail environment, it may not be as critical. Of course, you want that system to be available and operational as much as possible. But if you think about it, in any given day, a retail location is probably only open at most half of the day, right? Maybe 10 a.m. to 10 p.m. That's 12 hours. There's another 12 hours in the day. So you have the ability to bring the system down for downtime and maintenance and all that other stuff. So you only really have to have it available 50% of the time, whereas the website has to be available 100% of the time. So those are very different reliability requirements. Performance requirements. Again, going back to the web page example, for the web page, if a user clicks a button to complete a transaction, they expect it to complete within a certain amount of time. If it doesn't, they're going to move on and go to another site or go to a competitor. But in the retail environment, it can take a little bit longer for things to happen because you have a captive audience. The customer's there standing in front of you. They're not just going to walk away and go next door. There probably isn't a store right next door that sells those products. But then you do have some performance requirements because you don't want customers to think that every time they go to the store, it's going to take forever for them to complete a transaction because then they're going to go somewhere else. Security requirements, and these are usually requirements. No company wants to have to be secure, but we all have to, because if we don't, then we're going to lose our customer information. We could lose our trade secrets and things like that. So obviously, security is important. And again, in the web-based world, security is very different than perhaps what we would require in the retail setting. And that's not to downplay security in the retail environment. I'm sure most of you are aware of all these cases where people have stolen credit cards by using Wi-Fi sniffing and things like that. So certainly you have some security requirements at the retail side, but on the web side, you're really kind of exposing your information systems to the web, and you want to make sure that you have some security there. And also customers will be able to log in. So, to make sure that you have adequate security, that somebody couldn't steal a customer's credit card information or something like that. And of course, there'll be even more categories. Here's an example of some additional categories like design constraints, implementation, interface, physical, support, how you do installations and updates. So for interface, that would be like data interchange formats. Maybe, for RMO, they would have to support EDI because that's how they're going to interface with some of their suppliers. EDI is just the standard for interfacing with suppliers. So that might be something that they have to support. So those would be non-functional requirements. Let's talk about the stakeholders. In many cases, when I talk about stakeholders in class, most people are thinking of Buffy the Vampire Slayer, but that's obviously not what we're talking about here. The stakeholders in systems analysis and design are the people that are the beneficiaries of our product or of our system. So these are the people that are going to benefit from this system. They have a vested interest in the successful implementation of the system. So these are the people that want the system to be successful. So they're the people that we have to keep happy. They're the ones that we have to make sure are going to accept this system. You have internal stakeholders. These are the persons within the organization. You have external stakeholders, which are people that are outside the organization. For example, a customer could be an external stakeholder. They're going to benefit. A customer could benefit from the system. In the RMO case example, our customer benefits from the system because it's going to be they're going to be able to track all of their orders, whether they're a retail phone or online. They'll be able to use their rewards. They'll be able to track their packages and all kinds of stuff that they couldn't do before. Operational stakeholders are the people who interact with the system. So these are your phone operators, your customer support, customer service, the shipping and receiving clerks, all the people that have to interact with the system internally would be the operational stakeholders. The executive stakeholders, they don't directly interact with the system, but they use the information or have some financial interest. So, managers might be interested in the aggregate information collected by our system. So those would be the executive stakeholders. In our book, they have this chart that you see on the screen, which it's a little matrix of all these different types of stakeholders. So you can certainly take a look at that in the book if you like. In our example case, some of the stakeholders that we can identify are the order clerks. Those would be operational stakeholders. We have the warehouse and shipping personnel, again, operational stakeholders. They're internal stakeholders as well. We have marketing personnel who maintain the online catalog. Marketing, sales, accounting, and financial managers, that might be our executive stakeholders. And then senior executives, which of course are executive stakeholders. So these might be some examples of internal stakeholders. And then some external stakeholders might be customers and external shippers such as UPS and FedEx, which would certainly have something to benefit from this system. So these are just examples of some of the stakeholders and the things that the people that we have to keep in mind as we're developing this system. One example our book talks about for identifying stakeholders is you could look at the organizational chart. It might show you how everyone relates to each other and what their jobs and their roles are and who answers to whom can give you a lot of insight as to who your important stakeholders are in a project. In this example, we've identified that the Director of Internal Purchasing, AVB Production, Director of U.S. Purchasing, and the Director of New Design are our primary stakeholders in this project, just as an example. All right, so once we know who our stakeholders are, we talked about some different ways of gathering requirements. Let's talk about some specific techniques. So some specific ways that we can gather those requirements. The first one is interviewing users and stakeholders. We can also distribute and collect questionnaires. We can look at the artifacts, which are inputs, outputs, and documentation. So forms, reports, and documentation. I'll talk more about that later. And we can do observations. So we can look at the business as they're doing business. We can look at what people are doing, look at how they're interacting with each other and interacting with the current systems. And we can observe usually the pain points. We can look at other vendor solutions, which I already talked about. And we can collect active user comments and suggestions. So these are all the things we're going to talk about for techniques. Let's start with interviewing. So some tips for interviewing. First, prepare detailed questions for your interviewers. You want to meet with individuals or groups. It depends on who, obviously if we're talking to an executive stakeholder, it might be better for an individual interview as opposed to maybe some operational stakeholders where groups might be better. Obtain and discuss answers to the questions. So you're going to get the answer to your questions and maybe do some further discussion to clarify. You're going to document. This is very important. As you're doing an interview, you have to document those answers. A lot of us have a tendency to think that we're going to remember everything. I know I certainly do. A lot of times I'll go into meetings and, we're talking about something in detail and I'm thinking to myself, I'm not going to forget this. And then a week later, when I go to revisit that, I completely forget what we talked about. I don't remember what we were supposed to get done. But then somebody, I always call them the group scribe, always has everything written down and says, okay, you said you were going to do this and then we were going to do that. So documenting what's happening and documenting what you're discussing is a good idea, taking some notes. And then you want to do some follow-up as needed to maybe clarify things that didn't make any sense or maybe to get some additional opinions from the folks that you interviewed. Let's talk about some specific themes or questions you might answer. So 3 primary themes our book talks about is what are the business operations and processes? In other words, what do you do? How should those operations be performed? That would be the theme. So how do you do it? What steps do you follow? How could they be done differently? What information is needed to perform those operations? So what information do you use? What inputs do you use? What outputs do you produce? And again, this might be showing you examples. So, a lot of times you interview a user, an operational user, they'll say, okay, here's what I do right now. I take this form, I fill out these fields, and then I file it over here, and then so-and-so picks it up, and they complete this section of the form, and so forth and so on. So you're kind of seeing those artifacts in action. Preparing for an interview. So some things you can do before you go in for an interview. First, establish an objective. What do you want to cover in the interview? What do you want to get out of that interview? Determine the correct people to be involved in the interview. Obviously, if you're interviewing the wrong people, it's not going to be a very fruitful experience. Determine who the members are that are going to participate from the project. So not only determine who the people are that are going to be interviewed, but who in the project team should be involved in that interview as well. So who you're going to bring along with you. So maybe it's a good idea to bring a developer. Maybe it's a good idea to bring the DBA. Who knows? It depends on the scenario. You're going to build a list of questions and issues to be discussed. It's good to have a roadmap when you go into the interview. A lot of people think they could just kind of, meander through some questions and do a pretty decent job. And maybe that's true for some people, but you certainly want to have some idea. Obviously, we know what our objective is. But you want to build a list of questions as sort of a starting point. And a lot of those questions will lead to other questions, which is fine. But you want to make sure you have a starting point. So you're going to write down some questions to go into the interview with. You're going to review related documents and materials. Set a time and location is very important, and inform all the participants of the objective time and location. So most of us now in our workplace use calendar applications where we can send a calendar invite to everybody and say, on this date, at this time, we are going to discuss this project, and this is what we want to achieve in the discussion. That way, everybody has focus on what we're going to talk about, in the meeting. When they see it on their calendar, they know what to expect for that meeting. They know how to prepare for that meeting. I know a lot of times I'll see a meeting on my calendar and it just tells me whom I'm meeting with, and it doesn't have really the subject, so I don't even know how to prepare for that meeting. I just say, oh, it looks like we have a meeting at 2 o'clock. And then I walk into the room and we start discussing something. It's a lot better when I know what we're going to be discussing so that, I can kind of put my thoughts together and start formulating, how I'm going to discuss or, what we need to discuss. During the interview, some things. First, arrive on time. You don't want to lose time because you're late. And also, it doesn't look good when you don't arrive on time, especially with a stakeholder that might be kind of iffy about this project. Look for exception and error conditions, which we'll talk about later on. Probe for details. So keep asking questions. I always use the example of kids. For those of you that have kids, you might know that kids are very good at this. They'll keep asking why, right? It's that why game. Why is the sky blue? Why is the ocean blue? Why is, and it just keeps going on and on and on until you finally, you don't know, you can't answer that why question. That's how kids learn. It's how they're probing for details. So we can do the same thing. Take lots of notes. Document any unanswered or open questions that you're going to follow up on later. After the interview, some important things. Number one, the first thing you want to do is review those notes that you took. Very important to review the notes because the longer you wait, the less sense your notes are going to make. So you want to make sure you transcribe those notes into something more meaningful and something more detailed as quickly as possible. Even discussing those notes with somebody else certainly helps. Transfer to models and documents. So take those notes that you review and turn them into models and documents and narratives, which we're going to discuss in just a few minutes. So start to create those models right away while it's fresh in your mind, while you understand the workflow. Identify areas that need further discussion and send a thank you to the participants. Say thank you for giving me the time, et cetera, et cetera, et cetera. That's certainly a good step. In some organizations, maybe that's not necessary, but and of course, it depends on the project and things like that. But always a good idea to follow up with a thank you, and follow up on any unanswered questions. So anything that needs clarification, etc. So here's an example of an interview agenda. This is from your textbook, so you can certainly take a look at that in more detail. I won't waste too much time going over that here. This is an example of a questionnaire. I'm sure all of you have seen questionnaires. You've got some open-ended questions, and then you've got on the bottom there where you can say you strongly agree or disagree. Not all that unlike the course evaluations you do for instructors here at Drexel. Okay, next we have inputs, outputs, and procedures. And again, I like to call these artifacts. These are the current things that they use in that system. So these could be SOPs, which are standard operating procedures. Standard operating procedures are pretty useful because they give you an idea of the workflow. They start giving you business rules. Standard operating procedures usually tell you exactly what needs to be done, when it needs to be done, and how it needs to be done, which is exactly what we want. So if you have well-documented SOPs already, that's a good place to start. You can start looking through those SOPs. So SOPs might tell a clerk, what types of checks they're allowed to take, when they need to charge tax and all that kind, all those things. They might be documented in some kind of SOP. You can have reports. So any reports that get generated that people use. In your interviews, you might ask, what are the reports that you constantly use or that you need? What kind of reports do you need to see that you can't see right now? That might be a good idea to have. Forms that get filled out. These could be order forms. They could be internal forms. They could be web-based forms. Any kind of forms that you can look at to tell you what kinds of information have to get captured by the system. And again, I call all this stuff, collectively artifacts. I don't think your book uses that term, but you'll hear me use that term periodically. And again, that's just an old systems analysis and design term. So here's an example of an artifact, a customer order form. And this might be the order form from the catalog, right? So even though it's the order form from the catalog, this tells you probably what you need to know for the online forms as well, because you're going to have to capture all the same information. Some additional techniques. We can observe and document business processes, watching and learning. And then we can document those with an activity diagram, which we're going to talk about in the next unit. We can research other vendor solutions. So that can give us some insight as to what other people have done or how other people have solved this problem. And to be honest, with systems analysis and design, one of the things in structured analysis and design that we talk about a lot is it's not always necessary to develop a system from scratch. And in many cases, systems analysis isn't about designing a new software product or a new software system. For a lot of analysts, systems analysis is about trying to figure out which vendor has the system that's going to solve that problem. So that's an important part of systems analysis. We don't really talk about that in this class because we concentrate on the development of a system using OO techniques. But in a structured analysis class, you might talk more about how to vet vendors and figure out what's the best solution. So there's certainly a time and a place for all that stuff. But again, we don't really talk about that in this course too much. You can look at white papers, vendor literature, what other competitors are doing, what other companies are doing in your market space, and see how they've solved these problems. That can certainly give you some insight. Collect user comments and suggestions. So feedback on models and tests. So you might say, okay, here's what we're thinking about developing. Give us some feedback. Give us some suggestions. Do you think this is going to work? Is this not going to work? And finally, users know it when they see it. So users kind of know when they see something, they know how it's going to work. So that can certainly help. So finally, we're going to talk real quick about modeling, but we're going to talk about this in much more detail in Unit 2. So we really start to talk about modeling in Units 2 through 4. But just to kind of introduce you to some of the models that we're going to be discussing. First, how do we define requirements? After collecting information, we create these models. And these models help us visualize these systems and help us understand these systems. So after we get all these requirements and gather all these requirements and start to get a picture of that, we start to model those to represent each aspect of the system that we're building, and making sure that we understand that system, and that our users can look at those models and they can make sure that we understand that system. So some types of models that we talk about in this text are textual models, which is something written down, so a narrative or an explanation, a graphical model, which is diagrams and schematics, and mathematical models, formulas, statistics, algorithms, and so forth. For the most part in this course, we concentrate on graphical models and mostly using the Unified Modeling Language, or UML. So UML is an OO technique for doing modeling, and that's what we concentrate on in this course. Some examples of what those models look like in UML. You've got use case diagrams, which we're going to talk about in the next unit. In the unit after that, we're going to talk about class diagrams. And then in the unit after that, the last unit before our midterm, we talk about sequence diagrams, communication diagrams, and I don't think we talk about state machine diagrams until after the midterm. That's more of a design model. But these are some of the models we can use to take what we've learned in the requirements gathering. So all that stuff that we learn in requirements, we use to develop these models. We start with the use case diagram, which is a very high-level diagram, and we use that to build our class diagrams, and then the class diagrams help us create our sequence diagrams and our activity diagrams and all that stuff that we're going to talk about later on. So workflow, documenting workflow, which is a sequence of steps that handles one business transaction or customer request. One way we can do that is with activity diagrams, which describe user or system activities, and the sequential flow of those activities. So we're going to learn a little bit about activity diagrams. And I'll just kind of give you a quick overview of what those are and how they work. This is the syntax of activity diagrams. So you've got a swim lane heading, which you can see in this case, it says manager there. That's the swim lane heading, and you'll see why they're called swim lanes in just a second. The little dot is the starting activity, and then you got those ovals, which are the actual activities that are being performed, and the transition arrow shows you how we transition from one activity to the next, and then you've got the bullseye, which is shows that you've ended the activity. That's when the activity comes to a stop. If you look on the upper right-hand side, there's a bar, so you got an arrow that comes into a bar that then splits. That's when you have two. That's how you show concurrency, that two activities can happen at the same time. And then you've got a join, which is the opposite on the bottom of that. That's when the activities come together. So you're saying that that when those activities all come together, all complete, then you can move on to some other activity. And on the bottom there, you've got decision activity. So in the diamond, you have a transition into a decision. If the answer is no or false, you go one way, and if it's yes, you go another way. Not unlike a flow chart. So very similar to a flow chart. So some real world examples. Here is the order fulfillment activity diagram for the RMO project. We start the process with the dot, and then we go into finding location with sufficient stock. If we have sufficient stock, we pick the item from the stock, and then we decrement the item stock count and update the order status. And then obviously it stops at that point. And it also, for each item, then we transmit the shipping details, prepare the shipment, generating the tracking record, store the shipment record, transmit the shipment, receive the payment, and then we stop. So you can kind of get a sense of all the activities that happen. Notice the swim lanes here. We have 4 swim lanes. So we have our order subsystem, inventory, warehouse, and shipping company. And all of those systems have to interact. So this also gives you a sense of which activities are being performed by which subsystems. And notice, too, that in this swim lane, some of these systems are internal to our system, and some of these are actors or interfaces to our system. For example, the shipping company, they're not within our system. So those are interacting with us through some kind of interface, and those would be actors. Here's another example of an activity diagram. This one's a little different because it has some concurrency. We've got buying materials and programming the computer happening at the same time. So you can see a split and then a join. So this is an example that where you can see a split and a join in an activity diagram. So some reasons for modeling. We kind of talked about this already, but we're learning from the modeling process. One thing that's interesting about modeling is when you do models, the act of creating these models actually clarifies a lot of this for you. So when you're making a model, you really have to understand, you really have to know the business process. You have to know what it is that you're analyzing. When you write a narrative, it's not always evident that you know that. But when you try to build the actual model, you start to see these places that you don't have enough information, and you really start to kind of understand that stuff. It reduces complexity. Obviously, a model is a lot easier to understand than a than a narrative or something that's written. Written specifications are not always as evident or not always as clear as seeing something in action, which a model helps us see. Remembering all the details, so we can show all the details. Communicating with other development team members, so everybody can see exactly how the system is supposed to work. And communicating with a variety of users and stakeholders. So stakeholders and users, if you hand them a document that has 50 steps on it, I can almost guarantee you that no one's going to read it, right? Everybody's busy. Everybody's got other things to do. If you hand them a narrative that says, here's all the stuff you do, and it's 12 pages long, it's probably going to go right in the trash can. They're going to say, oh, yeah, I looked at it, but, they didn't really look at it. I'm sure all of us experience things like that. But if you give someone a model that they can very quickly digest and understand, it not only engages people a lot easier than a narrative. It's not as hard to look at a model as it is to read a long narrative. But it's also a lot faster for them to read it, and they can understand it a lot better. And a lot of times, I think with a model, you get a lot more meaningful feedback from your stakeholders and from your users. Finally, documentation. Documenting what was done for future maintenance and enhancement. So people can very quickly ascertain exactly what the system was supposed to do by looking at that model. So in this unit, we talked about the case example. We talked about what requirements are, how that affects stakeholders, some techniques to gather those requirements. And once we get those requirements, we talked about how we use modeling to try to demonstrate our understanding of those requirements and what we need in our new system. So in the next unit, we're going to talk about use case modeling. So we're going to really get into detail on how to develop use cases.